Thank you very much, Stanley. As Stanley said, I'm Graeme DeBrincat from Arup Facade Engineering, and I'm going to share the stage with Ava. We thought we'd split the presentation in two to try and make it a little more interesting and not have to just listen to me. So we've been lucky enough to do a little bit of research that we've called Rethinking the Life Cycle of Architectural Glass, which has been funded through our internal Arup Invest in Arup funding mechanism, which allows anyone in the company who has an idea to apply for some funding. And this research topic came about when I began working on this wonderful building in Glasgow in the UK. And this is an original photo from the opening ceremony of the Burrell Collection, a building in a park setting just out on the outskirts of Glasgow from 1983. It's an absolutely wonderful building, and this is the south elevation of the fully glazed cafe. And even in Glasgow, it gets rather warm in there. So we were dealing with glass technology from the late 70s and early 80s. So the project here is to renew this wonderful museum building with much more sustainable and using much more sustainable energy use. And we're trying to use all those latest technologies of coatings, double glazed units, etc., to improve the performance of the building. So to do so, we have to replace some 3,000 square meters of double glazed unit from the 1980s. So my first question to myself was, what are we going to do with all the glass that's going to come off this building? So I think, like all fine research topics, I Googled it, and I found that we virtually are recycling none of our construction glass in the UK, Europe, and indeed globally. So as I dug a little further, of course we found that there are recycling opportunities, and we recycle glass currently to road aggregates and to the little sparkly bits in road paint, and for glass beads for shot blasting, glass wool insulation. So there is some recycling. But I was really interested in trying to apply circular economy principles to get that glass back to the float line. And so I pushed a little harder to find out what was happening in the current state of play. So as I've said, there's around about 300,000 tonnes of glass coming off buildings just in the UK every year. About a third of that's going into those products I just described. And the other 200,000 tonnes is destined for landfill. I just couldn't accept that this was the answer that I was looking for. So I applied for some funding, and I was delighted to receive that funding. So we started to push and ask questions in the industry. So this research was really about finding out the current state of play, the state of the art in this topic. And I think as designers and engineers in the construction industry, it's our responsibility to move away from this take, use, dispose mentality. Look for a way to make this linear glass making process and turn it circular. So how can we get that glass from buildings at the end of its life? And for me, put it back in the glass melting furnace. I think the answer is not without some great challenges. So we started to look at those challenges, and of course this sketch made me able to sort of step through that more circular process. And of course, in each one of these steps, there's difficulties and opportunities, which is, I think, the most important part. So we need to rethink the life cycle of glass. We need to change our approaches. And I think the challenge I would set to you is to look at each of your individual spots along this chain and see, what can I do to make a small change, which might have a big impact on the glass industry. I think there's a huge opportunity here for post-consumer glass coming off buildings and being processed sufficiently to get high-quality cullet that's for the remelt purposes. So, of course, applying circular economy principles, there's a hierarchy of preferable solutions in decreasing in energy requirements as you go up the chain. So moving away from disposable disposal and other recovery, I think probably covers some of the products I've just described. Recycling in a closed loop, we're still only halfway up the triangle, but I think we need to be at least aiming there. And Ava, when she presents shortly, would like to talk about prevention and indeed preparing for reuse, which I believe is where we can really make a significant change. Excuse me. So of course, I haven't really told you why we should do this. But of course, putting raw materials into the furnace with a percentage of cullet, and that's pre-consumer cullet at the moment, is something that glass manufacturers are already doing. And indeed, the more offcuts from industry, etc., they can get, the lower the furnace temperature needs to be for the melting. So in our research, we found that almost all glass manufacturers are crying out for more high-quality, clean cullet. And of course, so by reducing that furnace temperature, we're saving energy in the production. Of course, the CO2 associated CO2 emissions. There's some numbers there. We're of course not taking that sand and the other components of the glass from the mining industry or from the ground. And there's other small savings as well. Of course, the reduction to landfill being very important. Some NOx and SOx effects. Increased furnace life. There's a whole range of opportunities where increasing cullet into our float lines is beneficial. I guess I started this process thinking that all glass should go back into the furnace. I probably quickly realised that that was not really the goal that we're going to get to. And indeed, there's a place for different grades of cullet. And having learned a little bit about the container glass industry, this is how they approach cullet already. Indeed, there's many grades of cullet useful for different products and different reuse opportunities or recycling opportunities. So I think it's important that we have a system in place, and we should develop that system as an industry, so that we know what material can be used in what products. One thing that's happened in the glass industry for container glass is this use of technology to improve the quality of the cullet that arrives by sorting, and so we have some fairly specialised and intricate equipment to do so, optical sorting and other devices, and this guy here who's able to pick out rocks in a flash. And I just wondered if there's an opportunity again for technology to be implemented into this procedure. So again, I think there's a call to arms there for our industry to look at different ways of changing that linear approach. This is a assembly of Arup projects that Arup often use on their website, and I think it's a really interesting image, a wonderful image, something to be proud of to work for a company like Arup. But when I look at that, I sort of start to wonder what year these buildings were built and which ones got the next glass replacement. We've got Lloyd's building hidden away in here somewhere, just there. It's now a short building, not a very tall building in London. And on that project, Graeme and others in Arup managed to recycle glass back to the float line. And that was some 6 or 7 years ago now. So we've got a precedent, we know it can be done, and now we've got a pilot project at the Burrell Collection in Glasgow to do it again. So I think that's the message I'd like to say, is that we can do this, and it's time for that change to happen throughout the industry. So I'd like to hand over to Ava, who's going to talk a little bit more about the next steps that we think we can design for the future.
Thank you. So taking it further from Graeme, I think also as designers, it's our responsibility that when we work on the projects and add to this skyline, we ask ourselves a question: what will happen to all these buildings after they're at the end of their life? And we can advise and consult with our clients and with architects to tell them how to utilize the materials the best way they can, and that we can introduce the circular economy into what we do and into the glass buildings, since that's what we're focusing on. So as Graeme mentioned before, this table kind of summarizes our findings, and it should help in guiding both for buildings that are built and for the new designs, what are the challenges or barriers that we are facing at the moment if we're trying to introduce closed-loop glass recycling for the glass coming off the buildings. I will talk through them, a couple of them. Maybe an interesting point to note is that the coatings are readily recyclable and they can just burn in the furnace, but there are other challenges that we have to face. Graeme said that before, but maybe here just again to emphasize that it was our choice to be ambitious and to try to realize closed-loop glass recycling, to go from architectural glass back to architectural glass. But there are other projects and other opportunities what you can do with the glass. This is just one of the examples. It's a project Verde in London, and there the glass that was replaced, 340 tons of it, was recycled back into container glass, so into bottles. So there are possibilities what we can do, and I think it's important to realize that it will be very project specific. You need to find a solution that will fit the project you're working on. And this kind of leads me to the challenges we might have. So there is a less and less iron content in the glass raw materials mix that we are using, because we're trying to eliminate the green color in the glass, and we're keen to have clear glass with low iron content. And that could actually pose a challenge, because there are many buildings that have higher iron content at the moment on the building. So when we try to recycle them, there might be a limited amount that we can use, because if we keep specifying the low iron glass, there is maybe a correlation between the iron content, so the color in the glass, and the recycled content that we put in there. And we have to keep this in mind, that we are not taking away from the opportunity maybe to recycle or use as much cullet in the process as we can. Next one, so ceramic fritting and tinting of glass, they both use components that have a higher melting temperature than clear glass, so therefore cannot be recycled in a closed loop, but cannot be put back into the furnace. How can we question this or progress this, answer this query? One of them could be simple. In the exposed edges of edge seal of double glazed units, if the workmanship on the edge seal is good, why would we need to hide it with the frit? It can just be exposed as it is, and that increases the chance for glass to be recycled. Of course, ceramic fritting is sometimes used as helps with the solar performance of the building, but it's also visual and architectural aspects to it. Instead of it, maybe we can use silicone-based opaque coats, or maybe we can print on the interlayers or add color interlayers to mimic tinted glass. However, we need to solve the next problem first, the laminating of the glass. So laminated glass also currently cannot be put back into the float line. The current practice in the UK is very crude, just crushing the glass, separating it from the PVB, with grinding it away, and it results into very kind of small pieces of glass, almost powder-like, and also the PVB that comes out of it is not very recyclable, usable anymore. But the glass is definitely not the Class A cullet that the float line manufacturers will take. So we can approach this problem from questioning why are we using so much laminated glass, but the answer is that usually the answer is safety. So maybe let's look at this from a different perspective, and let's ask ourselves, how can we delaminate the glass after the end of its life when we're taking it from the building? These are the slides from a video. We've been in touch with a company called D-Lam in Melbourne, Australia, and they delaminate the glass using heat and steam. They heat up the glass, they separate the layers. On the upper picture, you can see some interlayer being stretched in between, like chewing gum. They take away the interlayer, and what's very beneficial of this is this glass could potentially be reused, not only recycled. If it's annealed glass, it can be cut into a new shape. If it's treated glass, well, maybe it's just the size you need, but either way, you can put it back into the float line. You can recycle this glass. And this is just one of the examples that we've seen in the industry when we asked the question, how do we solve this laminated glass problem? Others that we've heard was maybe chemical debonding on demand, or there are potentially ideas of interlayers that are modified so you can just chuck them back into the float line and they melt. So we're here to discuss this, to see what's happening, but just also try to think out of the box how we can solve these things. The next challenge are insulated glass units. So the design life of framing is around 60 years, and the glass units have a design life of 25 years. And this is because of the double-edged seal. It starts to fail, your unit starts to condensate, and it's not really doing the job that it was designed to do. So it's definitely a weak link in that assembly. So currently what's happening with the waste processors that we've visited and had the pleasure to smash some glass, basically they put the units over the skip or over a frame they've built, and below it is the bag that collects this glass, and they smash it with a hammer. And as I said, it's exciting, but it's also quite labor intense, and for them it's kind of that makes it a consideration, what it's worth smashing and what not. So it can be dirty glass that they cannot be bothered to clean. It could be laminated glass, or it can be panels like in this skip maybe, that are just too small and it's not economical enough. It's not worth their effort to smash them. Another one sort of mentioned, it's the composite IGU. So maybe you have a laminate and a monolithic. There you have to maybe tilt the frame to get only the monolithic pane out and then deal with the laminate in some other way. So I guess then the challenge is that we need to maybe question the traditionally hermetically sealed glazed units, since they are the weak link, as I said, in this assembly. And maybe there's been some research within Arup. Graeme worked on this one as well. So it's the desiccant breather system that manages the humidity within the cavity, and it doesn't need the constant input of energy to do this, and there's no risk of condensation. Another good aspect of it in the middle, I think it can be replaced quite easily, and that kind of adds to long life of the facade. If it's easily replaceable, you can replace it inside, outside, you can change it with the technologies that we're seeing around this place, maybe PV units, you can adapt to the space if the function of the space changes, but it just gives you the opportunity to be a bit more modular. So we do really need to, from the early stage, think about design for this assembly. How will we not only install the facade units, how are the connections, are they easily accessible, how can we take it apart, but also when you have the unit, a double glazed unit, how can you separate all the different parts so you can harvest the most from all the things that come from it for spacer bars, glass, PVBs, and everything. On the left, it's an Arup example project, circular building, and I've just put it in here because it was also designed for this assembly. And you can see a couple of joints, so bolted connection, timber connections that are more easy to take apart and could be give us some food for thought how we can do this in glass. But so Graeme and I have been working on this for a while now. We have a published paper, and I hope, so for more information, go and read it, but also I hope this was interesting to you, that there was some new information, and that this starts a conversation or just thoughts in your mind, what we can do with glass that's already on the buildings, and how we can approach the future design of the buildings to introduce the circular economy concept into the glass industry.
Thank you.
And now we're happy to take questions.
Thank you very much, Graeme and Eva. Do we have any questions for them with regards to this? Hang on. I just realized I shouldn't be so comfortable in it.
Thank you. Great presentations, though I missed a part of it in the beginning. Could you say a few words about safety and standards? The reason why I'm asking this is that I've found out in various fields, not only within architecture or building construction, but the words safety It seems to be like a very hip word or something that it's so easy to point out in order to protect an industry or in order to protect the interest of a certain group of people, because then that gets into the area of being, well, it's difficult to say about it. There was a light bulb that could have lasted forever. There was nylon stockings that could have lasted forever, but the industry would not have had then next products if people have an everlasting light bulb or if people have an everlasting nylon stockings. So
Yeah.
would it be possibly so that our governments or our industry, it's in their interest to actually say, let's say the lobbyists of the corporations can also easily just point out that we actually need to have totally new glass, that the recycled glass or recycled building construction materials could not be actually used in order to protect their new business, because since they have an industry model or they have created something that functions well at the moment, and if there is a certain need to recycle and try to emphasize the circular economy concept also in building construction, they will lose some business.
I think I understand where you're coming from on this one. And in any circular economy activity, and I had the pleasure of going to a number of circular economy type events to talk about this kind of topic, and oftentimes with other industries there, which has been really interesting for me to see what's happening in food and beverage or automotive or other industries. And in this move to change to a circular economy, there's going to be winners and losers in industry. Isn't that up to the industry to move with that process, to be at the front of our games? That's what I believe we're here to be talking about, so that we're not the loser in that economic situation. So for business, in my opinion, business is moving to this approach. Does that answer in some way that question? Because there has to be winners and losers in any economic commercial situation.
I'd actually like to hear, since you come from the expertise of the technical side,
Indeed.
and if you could actually say something that is sort of, let's say, based on quantitative analysis or qualitative analysis of the safety of the recycled materials, because I could myself think that if we just keep on improving the methods how we recycle glass, that we could also improve the quality of glass so that it would become as good as the new one. But in order to do that, of course, we need to invest, and we need to have the urge to do so. And as long as we don't do it, we can still just, or the industry or those whose interest it is to remain in the business as usual, they can just keep on saying that, well, we cannot do it. So is it something that we could really do?
So absolutely, from a quality point of view of material, this is already happening. There's already at least 20% of recycled content in all float glass. That tends to be pre-consumer, so it's not glass that's been on buildings. In our discussions with the float manufacturers, all of them are keen to increase their content of recycled glass. There is no difference in product at the moment. There's one float glass product. There's not a high recycled content or low recycled content. There's still the high quality that we expect from our industry, using more and more available material from the buildings.
Thank you very much. Round of applause for Graeme and Eva, please.
Thank you.
Hi there. Did you like what you just saw? If you did, why not like the video? Drop us a comment below, as well as share the video with others, since GPD is all about sharing. And to receive more videos in future, subscribe and don't forget to click the bell icon for notifications. Ciao.